everyone. I'm sorry. Good day, everyone. I'm Kayode. I'll be taking you chemistry. When we say chemistry, what is chemistry all about? Chemistry is one of the branches of science. And what do we mean by chemistry? Chemistry is a branch of science that deal with the properties and compositions of matters. When we say matter, the word matter, what do we mean by matters? Matter is anything that has mass and occupies space. Now, what are the examples of matters? Now, everything in this universe is matters. When we say matters, we say shock. Shock is an example of matters. Yes, we say pen. Your pen is an example of matters. Pen is an example of matters. When we say matters, matter exists in three states. We have solid, liquid, and gas. When we say solid state are the matters that have what? They are the state of matter that have definite shape. They have a definite shape and definite volume. They have a force of attraction that are what? That give them their shape, which is what? Which is cohesive force. When we say cohesive force, what do we mean by cohesive force? Cohesive force is the force of attraction between the same molecule of a substance. Now, when we say liquid is another form of matter. They have a weak force of attraction. They have a weak force of attraction. Now, what are the examples of liquid? We have kerosene, we have petrol. Liquid, they can flow from one position to another. They can vibrate. Now, the third form of matter is gas. Gas, what are the examples of gas? We have oxygen, we have carbon dioxide, we have carbon monoxide. Gas, they can diffuse. They can diffuse from one position to another. They can occupy any available space. And then when we say matter exists as a chemical substances. What are chemical substances? Chemical substances are the substances that are single in composition. They are the substances that are single in composition. And which classify matters into what? Into three states, which are solid, liquid, and gas. Now, when we say properties of matters, we have physical properties and chemical properties. Now, what are the chemical properties? Chemical properties, they are the what? They are the properties that are unique to each matter. And then these chemical properties distinguish or classify these matters into elements, compounds, and what are mixture. When we say element, what do we mean by elements? Element is a substance which cannot be split into what? Into two simpler units. They cannot be split into two simpler units. E.g., we have sodium, lithium, and magnesium. If you look at the periodic table, when we say periodic table is just an arrangement of elements in order of increasing the atomic number. Now, when we say periodic table, now, if you look at the periodic table, you see the first 20 elements. Now, at this stage, our focus will be on the first 20 elements. Now, we just move further into the first transition method. When we say element, we have sodium, we have magnesium, we have silicon. They are the examples of elements. They cannot be split into what? Into simpler units. They have their own composition. They have their own properties, and they have their own chemical and their molecule properties. And as time goes on, we'll be treating each of these elements. When we say compound, what we mean by compound? Compound is the combination is when two or more elements are chemically joined together. Now, this compound, they cannot be separated because they are bound by what? By a force, by a chemical bond. Some of them are bound by what? By a force of attraction, which is electrostatic force. Some are bound by force of attraction, which is what? Which is intermolecular force. And then what are the examples of compound? We have sodium chloride. We have sodium chloride is a compound between what? Is the compound that contains sodium and chlorine. Also, we have marble or chalk. That's calcium trioxocarbonate is a compound between calcium and what? And a radical, which is which composed of carbon and oxygen. Now, when we say element can be classified into two. We have metals and non-metals. Now, if you look at the periodic table, the first representative element, they are classified into metals and non-metals. When we say metals, what do we mean by metals? Metals are the element that can what? That can conduct electricity. They can what? They can conduct electricity. Now they are malleable. When we say the word malleable, it means the word they can be what? They can be hammered into sheets. They can be hammered into. Some of them are lost up. At least they have what? They have sparkling appearance. They have sparkling appearance. They have shining appearance. If a light reflects, or if a light is incident on them, they can what? They can reflect it. That's what I mean by the word luster. Now, other properties of metals, some of them, they can be what? They are ductile. That is, they can be what? They can be drawn into wire. Like copper or silver, they are good conductors. So copper and silver, they are metal. But they are what? They conduct metal. They can be done. If you look at your observe, you will see some tiny wire in it. They are just an examples of metal. They are what? They are being drawn into that what? Into that wire. That's what I mean by the word ductiles. Now, some metals, they have, some of them may be soft, some of them are soft to the extent that they can be what? They can be cut by a knife. E.g., we have sodium, and then we have potassium, I mean. And then also, we also have some metals, some of them are, they have high density. They have high density, except magnesium and aluminum. Aluminum is a light metal. That's why they are used, they are being used to construct an aeroplane. Now, when we say non-metals, what are the properties of non-metals? Non-metals, they cannot conduct electricity. They cannot conduct electricity. They are brittle. When we say the word brittle, they cannot be hammered into sheet. They cannot be hammered into sheet. Each we have a diamond. Diamond is an example of non-metals. It's an allotrope of carbon. It cannot conduct electricity. They are no lusters. That is, they have no sparkling appearance. They have no sparkling appearance. Now, let's look at mixture. When we say mixture is a composition. It's when two or more substances are chemically mixed together. And then we have types of mixtures. One, although mixtures are classified into two, we have homogeneous mixture and heterogeneous mixtures. Now, homogeneous mixture is a mixture where their composition cannot be what? That cannot be distinguished. They cannot be classified. E.g., we have a solution, we have a mixture of water and sodium chloride, a mixture of water and sugar. Now, in this composition, they are uniform. They cannot be what? They cannot be distinguished. Now, we have heterogeneous mixture. It's a mixture, it's a mixture of two or more substances, which can what? Which can be distinguished. E.g., we have muddy water. Muddy water, you see, in the muddy water, you'll be seeing soil, the soil what will sink. You'll be seeing them, they sink, they serve as what? As suspension, or a marble or a chalk in a solution. You'll be seeing they are insoluble. You'll be seeing the chalk as a suspension in the solution. Now, another, we also have a mixture, we have tension of iodine, is a mixture of iodine and alcohol. They are also examples of mixture. Now, when we say we also have metalloid, what are metalloid? Metalloid are elements with properties that are intermediate between those of metals and non-metals. In metalloid, they can behave as metals sometimes, and also they can also behave as non-metals. E.g., we have graphite. Graphite is a non-metal, but it can conduct electricity. It behaves as a metal in conducting electricity. It also has some characteristics that are what? That are relevant to non-metals. Now, graphite has a mobile electron in its structure, which gives it its properties of what? Of electric conductivity. Now, let's look at when we say metals. Now, each element, let's look at each element. When we say element, each element has an atoms. When we say atom, what do we mean by atoms? Atom is the smallest particle of an element which can take part in a chemical reaction. An atom which can take part in a chemical reaction. An atom composed of three main particles: proton, neutron, and electron. Now, proton, the positive we see that the three particles that we have proton and neutron that are situated in that nucleus. And we have what? We have electron which revolve around the nucleus. Now, proton, in terms of charge, proton have positive charge, electron have negative charge, while neutron has a neutral charge. It has no charge. Now, the mass of proton, now taking guys, hello. Now let's look at Dalton atomic theory. Now let's look at Dalton atomic theory. Now there is a man called John Dalton. He proposed some theory which are pertinent to atom. He said atom of the same element. Firstly, he said every element has a small indivisible particle called atoms. Atom is the smallest particle that cannot be split, that cannot be divisive, that cannot be divided. And then number two, atom of the same element looks alike. The atom of the same element looks alike. And also atom of different, we say Dalton atomic theory. And Dalton atomic theory states that atom of the same elements looks alike. And then every element, every particle has the smallest indivisible particle called an atom. And this atom consists of three particles known as proton, neutron, and electron. And I've mentioned earlier that electron has a positive, has a negative charge, proton has a positive charge, and neutron has no charge. Now, let's look at the mass of an element. And when we say mass of an, what we mean by mass number of an element? Now, let's say in the periodic table, each of them has atomic number from 1 to 20. And then this atomic number is equal to what? Proton number. That means the number, the atomic number of every element is equal to what? To its proton number. Now, when we say mass number, what is mass number? Mass number is the sum of proton and neutron of what? Of an atom. Mass number is the sum of proton and neutron of an atom. That means the sum of proton and atom what are constitutes into the what? Into the mass of an element. Now there is this question that almost come out that they may ask you that the mass of an element concentrates in the what? Now the mass of an element always concentrates in the nucleus because those particles, the two particles that constitute the mass are proton and neutron, and they are what? They are present in the what? In the nucleus of an atom. And then this electron contribute least to the mass of an atom because this electron is not involved in the mass of an atom at all. There is also a question that we ask you that which of the following contribute to the mass of an atom? This should be an electron because it does not involve in the mass of an electron. Now, now we have a neutral atoms. What do we mean by neutral atoms? Now, neutral atoms is when the number of protons present in that nucleus is equal to the number of electrons. Now, element, when forming a what? When forming a compound, they may either lose electrons or gain electrons. E.g., that is why elements are classified. That's why I told you at the earlier time that elements are classified into metals and non-metals. First, the metals, they are the ones that what? That form a compound or react to what? To lose electron. They lose electron by what? By reacting with other elements, e.g., metals. And also, e.g., non-metals, Now, non-metals are the elements that react by what? By accepting electrons. Now, when we say a neutral atom, now neutral atom is when proton number is equal to what? Electron number. But when the element lose electrons, its proton number will exceed its electron number. That means the atom has become a charge. When the atom lose electron, it's what? It forms a positive charge. But when the atom gains electron, it's form what? It forms a negative charge. And then when an atom gains electron, His electron number has exceeded what is proton number. And then when an atom loses the electron, for instance, now we have sodium. If you view sodium atom very well, now elements, when it comes to atom, elements in their shell, we have principal quantum number, their energy level. The energy level starts from 1. We have first energy level, second energy level, third energy level, fourth energy level, and so on. Now, the first energy level, which is always represented as K shell, which is shell 1. We have shell 2, shell 3, shell 4, and so on. We have K shell, L shell, M shell, and N shell. Now, the K shell can only occupy 2 electrons when distributing electron into what? Into the shell of an atom. The K shell can only occupy 2 electrons, while the L shell can occupy 8 electrons. The third shell can occupy 18 electrons, but when we are considering the first 20 elements, it can occupy only 8 electrons. Mind you, I told you the M shell can occupy 18 electrons, but when we are considering the first 20 elements, it occupies only 8 electrons. Now, take a look at the atoms. When distributing electron into the shell, the K shell can only occupy 2. Let's say, for instance, sodium, for example, the atomic number of sodium is 11. That means the proton, the electron number of sodium atom is 11. Now, if the first shell, which is the K shell, occupy 2 electrons, we have how many left? We have 9 left. Now, the second shell, which is L, occupy 8. We occupy 8. Now we have only 1 left. Now that means the third shell will consist of the remaining 1 electron. Now, when sodium atom is going to form a compound with another element, no matter, it will lose its outermost electron. The single electron that is in the outermost shell is called the outermost electron. It's also known as the valency electron. It's the electron that is present in the outermost shell of an atom. Now, this is this electron that sodium atom will lose in order to form a chemical reaction, in order to react with another compound. It will react by losing that 1 electron. Now, mind you, if sodium loses that electron, that means its electron number has decreased. It has lost 1 electron. It has decreased in electron number. That means the proton number of sodium is no more equal to to the electron number. That means sodium atom is no more a neutral atom. It's now become a charge. Now, how do we know the charge? Now, a charge, let's say a positive charge. When we say a charge, now the number of electrons lost by an atom will be the charge that will be present in the on the atom. Now, first, sodium atom now lose 1 electron. That means it will have 1 positive charge. Because it loses electron, it will have 1 positive charge on its atoms. Now, let's say chlorine. Now, chlorine is has atomic number 17. That means it has a proton number of 17. Now, in the first shell, we occupy 8. And the fourth, which is the N shell, we occupy 1. Now, we occupy 7, and the third shell, which is 7, the N shell, 7, in order to complete the outermost shell, to make it 8 in the outermost shell. Now, when chlorine gains electron, it's formed a negative charge. That means the electron number of chlorine has exceeded the proton number of chlorine. Now, chlorine is no more a neutral element. Now, let's come back to sodium. Now, when sodium loses 1 electron, now the question is this: you may be given a structure. They may write the sodium atoms. Now, they will ask you that if this element, or if an element, just like, let's say, element M, which has a proton number of 11, lose 2 electrons. Now, what will be is electron number and proton number. Mind you, the proton number, which is atomic number, remains the same. The proton number does not change. The atomic number also did not change, but it's what? Its mass number, its electron number has changed. Now they may give you sodium atom now for example. Now they will give you that, okay, sodium atom has an atomic number of 11, and then they will write a positive charge. A positive charge, that's 1 plus on the word, a plus, which is positive charge on the atom of sodium, the proton number of sodium. Mind you, the proton number is 11, but electron number is what? Is 10, because it has lost 1 electron. Because it has lost 1 electron. Now we have some elements, and also we have some elements that exist in 2 or more forms, which lead to what? Which lead to isotope. Which lead to isotope. Now, isotope have an atom of the same element. Now, when we say isotope, now isotope are atom of the same element with the same atomic number but different mass number. Now, when we say isotope, now we said in Dalton atomic theory, Dalton mentioned that atom of the same element looks alike. But here there is a contradiction, which is an isotope. Now this serves as the modern atomic theory. There is a contradiction to what? To Dalton atomic theory, which say that atom of the same element looks alike. Here now, in isotope, we have elements, the same element. We have the same atomic number, but different mass number. And then when we say mass number, when we have the same different mass number, what causes the differences in their mass? Now let's come back to the nucleus of an atom. We say nucleus of an atom, we have proton and neutron, and the mass number of an element is concentrated in the nucleus of an atom. Now, what causes the changes of what? Of mass number? Now, I told you earlier that the proton number of an element is equal to what? To the atomic number. And in definition of isotope, we have the same atomic number and what? And different mass number. That means there's no change in the what? Change in the proton number of the 2 atoms. Now the only changes that is what? Is the changes in their what? In their neutron numbers, which is contradicted to the one of the Dalton atomic theory. That means atom of an element, isotope, deal with atom of an element which have the same atomic number but different mass number. Now, let's take a look at chlorine now. Chlorine as an atom, we have chlorine 35 and chlorine 37. Now, chlorine 37 now, when it comes to calculation, you see chlorine 37 exists in relative abundance. In nature, it exists in the what? In the 25% in abundance. Its abundance ratio is 25%. Why that of chlorine 37 is what? Is 75%. And when it comes to calculation, maybe the next class we try to do calculation to solve some problem under isotope of an element. We like to solve some problem under isotope of an element. Any question? Hello, can you hear me? Any question? Do you understand what I'm saying? Do you understand me? Any question? Okay, let's continue. Now, let's look at periodic table of an element. Now, when we say periodic table, now how is element arranged in the periodic table? Now, elements are arranged in order of increasing atomic number. Now, each element are arranged in the periodic table in order of what? Increasing atomic number. Now, in the periodic table, we have some periodic properties. What are the properties of periodic table? We have electronegativity, we have electron affinity, we have ionization energy, we have electropositivity and atomic radius. Now, when we say ionization energy, what do we mean by ionization energy as the properties of periodic? Now, ionization energy is the energy required by a metal to lose electron. The energy required by a metal to lose electron. Now, we said that when they're going to take part in chemical reaction, they do lose the electron in order to react with other elements. They do lose electron in order to react with other elements. Now, the energy required for that metal to lose electron effectively is called an ionization energy. And then this ionization energy, if you come to the trend of periodic table, now in the periodic table, we have group. Elements are arranged in group and period. Now, when we come to group, elements, we are going to fit elements into group. We fit elements into group based on the what? Based on the number of electrons they have in their what? In their outermost shell. Here now we have sodium. Now we have K element, and we distribute electron of sodium into what? Into each shell. We say K can occupy 2, L can occupy 8, and M can also occupy 8. Now sodium, the first shell will contain 2, second will contain 8, that's 10. The remaining one will be in the what? In the L shell. And then this L shell, we have one outermost, we have one electron in the outermost shell. Who is the outermost shell? Now, this L shell, now this electron, one electron, since it is one electron, that means sodium will be in what? In group 1 in the periodic table. Now, if you move to magnesium, you see the outermost shell of magnesium will contain 2 electrons. That means magnesium will be under what? Group 2. Group 3, that's aluminium. If you view the atom of aluminium, it has 3 electrons in its outermost shell. That means aluminium will be what? Will be under group 3. Now, and so on, we have period. We have group 3, we have group 4, group 5, group 6, and group 7. Now, when it comes to group 5, if you look at the outermost shell, they have 5 electrons in their outermost shell. Group 4 element have 4 electrons in their outermost shell. Group 7 element has 7 electrons in their outermost shell. And then we have group 8, which are noble gas. They are stable. They have completely filled shell, outermost shell. Their outermost shell are completely filled. They do not take part in chemical reaction. They are called noble gas or inert elements. They are called group 8. They are fall under group 8. E.g., you can see helium, argon, and neon. They are noble gases. Now, when we come to period, we arrange elements. We place elements into period based on the number of cells they contain. 1, we have hydrogen now. Hydrogen has only K shell. It has an atomic number of 1. It has atomic number 1. It falls under only K shell. That means hydrogen is placed in what? In period 1. If you look at helium, number 2 in the periodic table, in the first 20 elements, helium has atomic number of 2. And then the K shell can occupy only 2 electrons. The K shell can occupy only 2 electrons. Now that means the helium also the K shell fall under K, the helium fall under K shell. That means the K shell can occupy only 2 electrons. Now the K shell, that helium also fall under period 1. Now, if you look at lithium has atomic number of 3. Now, when you are going to distribute electron into the shell, now the K shell will occupy 2. Now, it will remain only 1 electron. Now, the 1 electron will be fit into the L shell. That means lithium has 2 shells, which is K and L shell. That is to be placed under what? Under period 2. Now, that means elements are placed in the period based on the number of shells they possess. And then elements are arranged, are placed under group based on the what? Based on their outermost electron, based on the number of electrons they have in their outermost shell. Now, when we say electron ionization energy, when it comes to the trend, now ionization energy increase across the world, across the period, and decrease down the group. They increase across the period and decrease down the group. Now, when we say electron, let's look at electron affinity. Electron affinity is the energy required by a gaseous atom to accept electron. To accept electron is the energy required. For instance, now we have chlorine. Now, chlorine reacts in the chemical reaction. Chlorine will accept electrons in the chemical reaction. Now, the energy required by chlorine to accept electron in order to have an octet shell is electron affinity, is the energy required for chlorine to accept electron. Now, when it comes to trends of periodic table, the electron affinity increases across the period and decreases down the group. Now, chlorine has 7 electrons in its outermost shell. That is falls under group 7. That means group 7 element has the what? Has the highest electron affinity. Group 7 element has the highest electron affinity. Now, if you look at the periodic table now, the first 20 elements, the group 7 element, we have fluorine and chlorine. Now, if you go into the transition metal, we have chlorine, we have bromine and iodine. That means we said electron affinity decreases down the group and increases across the period. That means the non-metals with the highest electron affinity is fluorine. Fluorine, we have the highest electron affinity. Now, let's look at electronegativity. When we say electron, what do we mean by electronegativity? Electronegativity is the tendencies of an element to attract shear paired electron toward itself. You know, as time goes on, we look at chemical combination. When elements react, some elements react in terms of what? Electron transfer. Electron has been transferred, like sodium and chlorine now. Sodium will transfer electron, chlorine will accept it. But in another chemical reaction, we also have another type of bonding in which electrons are being shared. Now, each element will contribute by what? By donating electron, the shear electron between them. But the one with the highest electronegativity, the shear electron, the electron that is being shared between the atom, the one with the highest electronegativity are what? Do attract the shear paired electron. That we call electronegativity. And then electronegativity, when it's come to, we have some compound. We use electronegativity to determine whether a compound is polar or not. For instance, now we have water now, or sodium, let's say sodium chloride. What is it? It's an ionic compound. When we say sodium chloride is an ionic compound. Now, we also use electronegativity to determine whether a compound is ionic or not. Now, for instance, the electronegativity between sodium, if electronegativity of an element or of a compound, electronegativity between elements that constitutes the compound is below 0.5 or is less than 0.5, the compound is said to be what? Non-polar. Now, how do we determine it? Now, you will subtract the electronegativity of each element. The differences in the electronegativity, each element will have its own electronegativity. Now, for instance, now we have sodium chloride. We have sodium chloride as a compound. Sodium will have its own electronegativity. Chlorine also has its own electronegativity. The difference in the electronegativity, if it's less than 0.5, the compound we have to be a what? Non-polar. The compound will be non-polar. But if it's equal to 0.5 and also exceed 0.5, the compound is what? Is polar. But if the electronegativity between the two elements is equal to 2 or more than 2, the compound is what? Is an ionic compound. I hope you understand what I'm saying. Now, let's look at atomic radius. Now, atomic radius, when we say atomic radius, now, okay, sir. Now, we have atomic radius, and when we say atomic radius, now, I'm sorry, we have to quickly take a quick recap of what we've learned so far. Now, we've learned about matter. We said matter is anything that has mass and occupies space. And we may mention some states of matter: solid, liquid, and gas. And we give examples of solid. We said pen, book, chalk, and so on. Also, gases, we may mention of carbon dioxide, carbon monoxide, and oxygen, and so on. Liquid, we have kerosene, water, and so on. Now, we mentioned of properties of solid. We said they have definite shape. They have strong cohesive attractive force. They can vibrate at a fixed point. They can vibrate. And then we discussed the properties of liquid. Now we said they have a weak attractive force. They can rotate and vibrate. They can diffuse slowly. And also we discussed gases. Now gases has the most weakest attractive force. Now they can occupy any available space. They can occupy any, and they can diffuse. They can diffuse rapidly, and also gases can move. They can vibrate. They can rotate, and they can also translate. I think this is the end of the class. We'll be continuing in the next topic.
Someone has a question. Someone has a question. Please go
Any
ahead.
question?
Unmute yourself.
Okay, sir.
Grace.
Okay, the class is over now. I think I have 1% here. Yes, I have. This is 1%, sir. Hello, sir.
We'll continue. Oh, sorry, we won't be able to attend to your question now. I think we have some technical errors. We would continue in the next class. Please tell your friends and subscribe to our YouTube channel and tell your friends to register for this free online tutorial. Thank you. See you next class. Bye.